All right, welcome to 5 Live Free Coding School. Okay, cool. So I've been looking forward to this. When we were last together about a week and a half ago, I'd asked you to work on building out a comparable CRUD application to what we had built. And instead of being centered around products, centered around customers. Did either of you get a working product on that?
I did, yeah.
Excellent. Sudesh, were you able to complete it or get some way into it?
I have started.
Okay, good.
I wasn't in last 2 classes. I had to go through the recording.
Oh yeah, you had to catch up. Okay, good. Well, this will be good for you to see what Alexander's come up with. And then depending upon how much time we have at the end of the day today, I want to get into version control. And if not, then we'll pick that up on Wednesday. But for now, Alexander, do you mind sharing your screen and we'll take a look at what you built?
Sure. 1 second.
Excellent. All right, why don't you take us through the structure of your code first before you show it to us running, okay?
Okay. Well, the first thing is I switched to a different package. Hopefully that's okay.
Yeah.
I found one called Inquire that I felt like kind of solved some of the issues we were having with the prompts one.
Oh, for accepting data from the command line?
Yeah.
Oh,
it
that's
kind of like
excellent.
lets you just like do like you have like a drop down list of choices you
Ooh.
can choose from. So I thought that was kind of cool.
Oh, nifty. Okay, good.
And then it basically just does like all the same things. Like
Yeah, it's
I
got the
have
switch
the
kind of syntax built into
create,
it.
yeah, and then the update, and then delete, and then the
Oh,
read. And I added an
excellent.
additional read by username or by ID.
Oh, great idea. Great. Okay. And so you have on the left there the app.js. That's our entrance point to the app.
Yeah.
Then you have a data folder and an operations folder. Okay, good. Show us how the data folder works.
All right. So I have the customers in JSON,
Okay.
and then I have the copy. So then, like, if I mess this up, I still have that.
Oh,
And,
good. Excellent. Okay.
The highest ID to keep track of that.
Oh, good. Okay.
And then the import's added to get the information.
All right. Let's look at that real quick. That's pretty much the same thing, right? Where we're going to scan through one line at a time at the customers.txt file. Okay, good. Excellent. All right. So yeah, go ahead and run it.
I might have to, I think I have to switch folders actually. 1 second.
Yeah.
There we go.
If you like to create, read, update, delete. Oh, the arrow keys. Oh, you can arrow down to what you want.
Yeah.
All right, give us read by ID.
Okay.
Oh, and it switches out. What I see why you like that Inquire library.
Yeah.
All right.
And then so like one will output the first
Bob
ID.
Z, Bob's Burger. Okay, totally separate question from coding. I see that people love that show. Haven't seen it. Why should I watch it? What's awesome about it?
I think it's because there's a lot of different like adult cartoons where it's like American Dad, Futurama. So it has that kind of funniness, but it's like way more wholesome. Like it's about like the family. So
okay, I like that. Okay, good, awesome. So you're popping out the JSON onto the screen. That's excellent. All right, give it to us again. And I want to see how the username works. Are you're going by not by email, but by what their username is, right?
Yeah. Yeah.
All right, let's see that. Give us Tina.
I don't actually remember what the username was for that one. Hold on.
I think it was Tina.
Username.
No. Yeah.
Glasses.
Username Glassesburger. Okay, I see.
Yeah.
Excellent. Actually, why don't you go and run it again? Show us the full list of all of them.
Okay.
I really like that library. That's so much more user friendly. Bob Z, Bob Linda, Burger. Excellent. Okay, good. Now I want to see an ad.
Okay. So create, so username.
Excellent. And then run it again, show us all. Awesome. There's Gene. Okay. Can we delete Lil Burger ID 3? Good job. Okay. And finally, show me how the edit works.
And so you can like how we had it before, where you can just skip one. If you skip one of the lines, it will still be like just update accordingly.
Awesome. Okay. And I'm just interested because I want to see it. Show, we ran into that weird problem with the prompt library. Show us how this inquire library handles, like, where's your code for update? It's down in update.js, right?
Yeah, I just have the update here.
Okay, so there's update customer. It takes a customer object and an ID.
Yeah.
Okay, and the updated customer is all the info you collected from the command line.
Yeah.
Oh, beautiful. So show me in app.js how it handles that prompt update. Okay, so first this is inquire.prompt on line 57. Okay, and then we read the customer by ID on 60. So we get the current customer. And then, see, so you can have a nested prompt inside this case.
Yeah.
The case begins on line 56, but with a nested prompt on 61. Good job finding that, Alexandra. That's excellent. I mean, again, that's not normally how you build a UI, but it's just a really good example of like taking a constraint and finding the best solution given that constraint. And that's another just comment on coding in general. In virtually every project, there are some constraints. Some of them are, relatively minor. You have a project where you're free to choose lots of technologies. You don't have to interact with a lot of other existing applications, that kind of thing. And there's very few constraints, but that's not very common in development. A lot of the times you have lots of constraints, certain technologies you have to use, certain core libraries of code that your company's developed that they want you to use, certain database technologies, that kind of stuff. And you have to build around that and find a way to make it work. So you do your best work, frankly, when you have these constraints. So that's excellent. Well done. What were some things that you found particularly challenging, and how do you get through them?
I definitely struggled a bit with the update. I don't like when I first did this part with the ternary operator.
Oh yeah.
It wasn't working. And I don't even I think I rewrote it the same way. So I'm not even really sure what changed. I think maybe what I had before was this part was first.
Oh,
I
right.
had listed
right.
here.
Right.
I think that was what I made the difference for there.
Excellent. So yeah, ternaries are nearly always really interesting to kind of work out, but they're so concise. I kind of like them. There's nothing wrong with having, an if else and have it taking up more space. Nothing wrong with it at all. But no, that's excellent. Good.
Yeah.
Good. Okay, cool. Sudesh, does this, first of all, I recommend that you try to figure out how to use that library. Go to the top where you import this Inquire library. Number one, import Inquire from Inquire. Okay, good. So you just did an npm install Inquire to get that to be part of your project, right?
Yeah.
Okay. Sudesh, do you have any questions seeing this run?
No, I probably need to explore what Inquire is. I was going through prompt.
Yeah,
library.
And you can build it with prompt. There's nothing wrong with that, Sudesh.
Yeah.
Nothing at all.
Yeah.
I really like this. That's
Yeah.
pretty cool. Wow, neat little, that's a really, really cool little library. I'll remember that. Okay, good. All right, then what I want to do is let's switch a little bit. And Sudesh, I'll give you more time to go ahead and build out your own, but please do finish it. I want you to build a full CRUD application. There's not a lot to this, but it's precisely because it's pretty small and contained that it's worth building a second one of these on your own. What was your experience like doing it, Alexandra?
It was pretty good. I think the classes helped a lot because anytime I started to feel like I was getting stuck, I knew how to do like use the breakpoints and use the debugger to figure it out
Good.
quickly.
Good. Excellent. Yeah. When in doubt, run your code to see what it's really doing versus what you think it's doing.
Yeah.
That's it's pretty wild. What you're like, oh, I got that exactly backwards. My greater than should be a less than, and you didn't even catch it when you're scanning through the code, you know?
Yeah.
Okay, good. Yeah, as you're building this out, Sudesh, if you have questions about the Inquirer thing, Alexandra, just ping Alexandra and say, hey, listen, what did you do here?
Yeah.
So that kind of cooperation and help is really, really cool. Okay, good. All right, what I want to do is do some work on version control. Okay. And I want to start by just talking about a little bit of the history of like where the heck did what is version control? Why do we care about it? How was it done for a long time versus how is it done now? Can either of you take a crack at like explaining what you think version control is?
It's about managing the change to the program you build.
Oh, I like that. About managing change in a project. That's actually a really good description. Alexandra, any thoughts on that?
I think it's like managing multiple different versions so that you don't like break another version while you're working on something separate.
Yeah, that's another really good aspect of it. Exactly. Let's dig into this a little bit, and we're going to step outside of the realm of coding and just talk about what version control is outside of the world of programming. Version control is the act of using a computer program to keep track of the version history of a set of text documents. We always, as engineers, think of it in terms of our computer programs because that's what we use it for. But recognizing that at its core, you're going to be using computer programs that are all about text documents. That's all they are. The programs you're going to use have no concept of what a computer program is. We're only going to be working with text documents. And that will lead to a lot more understanding of the process of software development and the software development lifecycle later on. But for now, that's the first thing to realize is version control is just using computer programs to keep track of different versions of text documents. And again, those text documents, they are what's going to be turned into a running computer program. This is just a jump on the Wayback Machine. Can one of you take a crack at explaining what source code is? We covered this a few months ago. Source code is the text documents that get fed into a compiler so that the compiler can then produce running machine language, your actual computer program. So you've got the compiler in the middle here, a specialized little utility. You feed into it text files like we see on the screen here. And what comes out of the other end is machine language or binary code. So it's called source code because it is the source for the compiler program. And the output of that, or the destination of the compiler, is machine code. So that's what we call source code. So you'll hear terms like source control a lot, source code, and it's all the same thing. It's version control. It's just that the text files you're working with happen to be the text files that will be fed into a compiler to be turned into machine language. They are the code that becomes your running program. Any questions on that?
Based off that, is there anyone who's ever working like not with source code then? Or is that like just 100% the computer?
Idiots.
Okay.
Idiots do that. and very, very, very new programmers or super experienced programmers who think that the project they're working on, because nobody else is going to see it, that it's just too much hassle. And those people are, and I've been it, idiots. Just use source control all the time, even on your own projects that are only going to be on your machine and nobody else is going to see, because it's inevitable that you'll make a major screw up and go, well, I could take the next hour and reverse everything I just did, or I could issue one command and revert back to the way things were an hour ago.
Oh, okay.
And it would take like 5 seconds instead of an hour. So yes, everybody uses source control. That's a good question, actually. Yeah, everybody is. Now, let's step into how source control was done a long time ago. I'm gonna do a little bit of poking around on the internet here. So let me go ahead and take over and share my screen. So let's see if I can find. Can someone tell me what client server is? What's it an example of?
When you're like retrieving something from a database, is that like a client server?
That's a very, yes, it is. The answer to your question is yes. But I want to go a little more abstract. What is client server an example of?
Would it be like your own, because I know like your computer is technically like the client, so then when you're like searching something on the internet, that's through a server, right?
Yeah, good.
Okay.
Yeah, these are all very concrete examples of what client server is. What I want to do is step above that and just look at the idea that a client server arrangement is one example of a thing called a network architecture. You can organize networks a variety of ways. You could, for example, have, here, let's do this. You could organize a network like this, where if you want to send information to other computers in the network, you only have a connection to the ones on either side of you. So if you want to send something from the top one to this one right above the word hope, you have to send it through either this one or these two to get to it. That's one way of architecting a network. Another word for it is topology, like the arrangement of the computers and their connections in a network. So you can call it a network configuration or a network architecture. It's one way of arranging a network. A client server is a totally different philosophy. One central computer and all of the computers that use it are connected to it. You can't communicate from one computer to the other. That's a client. You have to communicate through the server, and then you can get information to a client. It's just a different architecture of a network. Now, as an entry-level engineer, you don't need to know a tremendous amount about how to how to organize these networks. Okay, you'll find that you learn more and more as your career advances, and it may be that at some point you have a job that is a little closer to that and it matters more, and then you just do a deeper dive and learn about it. But for right now, I just want you to know that when we talk about this client server arrangement, it's only one of many possible ways to organize a network, and they're all based around what do you want to do. Now let's be a little more precise. There's only two things a computer does. A computer is meant to take in information, process the information, and then send it on. Remember, that's the purpose of a computer back from like session 1 when we started a while ago. Okay. The processing of it, that is work that you do for someone. So the only reason you're going to connect two computers together is because you want to make decisions about who's going to do the processing, who's going to do the work. That's why you connect computers together. Computers have, again, as a purpose to take in information, process it, and send the information on. We found it necessary because of the scope of the work involved or the type of work involved. Many years ago, we found it necessary to connect computers. The network was born. So part of why you would organize networks one way versus another is who's going to do the work. Now, in a client server model, when they first started, for the most part, the server was where the work got done. It is of service to all the client computers. Now, the fact is, though, that every single one of those computers is itself, ready for this, a computer fully capable of doing work. So you'll find that the server can do two different types of things. You can send information from a client to the server for it to do the processing on, or the client can say, hey, can you give me some data that needs to be processed? The server will say, yeah, sure, here it is. The client will do some processing of it, and depending upon what the needs are of your system, send something back now that it's been processed. So the fact is, where the work is done can vary based on what the needs are of this system. Because again, they're all computers. They're all capable of taking in data, processing it, and sending it on. Big picture. A client server model in general is an arrangement where one computer provides a service to many other client computers. That's in general. Clearly, there can be nuances here. So we haven't even started talking about version control yet. So I'm going to review client server. Any questions about this? Okay, so let's think about what's needed in this idea called version control. We're going to have a collection of files. We just saw a collection of files on Alexandra's computer. That collection of files is much more than just a bunch of text documents, though, because she did something magical. She used a compiler, and it slurped up all of those text files and turned them into a running program. And we watched that program run on her computer. It was really cool. That collection of files right now sits only on her computer. So let's just change the scene a little bit. Let's say it's around the year 2000, and all three of us work for a computer software company, and we are, in fact, building a customer management application like the one that Alexandra just demonstrated to us. And each of us, at various times in the the span of time where we're developing that computer program, are going to have different projects, different duties, different things we need to do. We're all going to contribute. What we could do is take the set of files and put one copy of it on a server. And then our laptops, well, it's the year 2000, so probably our desktops, they are the clients of that server. That server would be called a version control server or a source control server, a build server, lots of names for it. But the fact is, it holds probably the most important intellectual property that the company possesses, our source code. With our source code, we can produce a working computer program, which we can sell to people and make money. So now, whenever any of us wants to work, here's how it would go. Let's say this one on the right is Sudesh. And Sudesh has been given the job Monday morning of, hey, Sudesh, I need you to build out the read customer by ID function. Sudesh says, oh, good. He connects to the server and says, show me all the products. Sorry, show me all the files in the project. The server sends back a list of all the files. He scans through them and goes, oh, it looks like I need to work in this file that Alexandra created. It's empty, but it's there. It's called let's see. No, what was your file called for searching, both by ID and by username?
That was my read file.
Read. Okay, good. So Sudesh looks through that list and says, oh, there's the read.js file. That's what I need to work on. Now, remember, all he has is a list of these files. He doesn't have all the files. They're right here, sitting on the server. So he goes, okay, well, hey, server, I want to edit the read.js file. The server goes, oh, okay. Well, no one else is working on it. So sure, here's a full copy so you can work on it. And meanwhile, so that nobody else can make changes that'll conflict with what you're doing, I am going to mark that file as locked. And it's been locked so that only Sudesh can access it. Sudesh does his work, adds in this function called read customer by ID or whatever it was, and says, okay, it looks like it runs, everything's fine, and checks it into the server. What that means is the server says, oh, thank you. I will now put down this new version of the file. I'm still going to maintain a copy of the previous version because my job is version control, but I'm going to make this the newest, latest version of read.js, and I'm going to unlock the file. Any questions so far? Okay. Now, this is safe, but a giant pain in the butt. Let's say that while Sudesh was working on this, Alexandra, you realized that your search, find user by username had a little bug in it or needed to be improved a little bit. You can't work on that file because it's been checked out for editing by Sudesh. This is you over here. And you go, hey, let me work on my read.js because I found something I really want to fix or make better. And the server sends back, oh, sorry, you can't have access to the file. It's locked by user Sudesh. Ah, dang it. You got to figure out something else to work on. So bit of a bummer, bit of a drawback. Now, what's the advantage here? Why would this sort of a system be liked by companies?
Would it be so that like you don't have anyone just going in there and messing something up? Like you don't want two people who are communicating working on like the file at the same time without knowing what the other one's doing.
Yeah, absolutely. That's good. It prevents conflicts in a file due to people not communicating well and organizing their work. That's a really, really good point. Now, here's another thought. Here we are, and this server is where these files are. Where do you think this, back in the year 2000, physically, where do you think this server would be?
In a building where the office is.
Yeah, probably in the actual company's offices. Why? Why wouldn't they like put it down the road in like some big professional building where all they did was have a bunch of servers?
Would it be because it's closer so they can fix it if it like breaks?
Yeah, there's an advantage, yeah. But let's say that the company that provides these servers, they've got dedicated technicians 24/7 and they can spin it back up again. In fact, they maintain a separate copy of the server that gets synced, every 5 minutes so that you're safe. Why would you not want to do that? Any other concerns a company might have?
Security.
Good. Expand on that. What do you mean?
It's so nobody else out of the company can access the data.
Yeah, that's exactly it. That's exactly it, Sudesh. while these are only text files, they are unbelievably valuable text files. Let's say that the team right here in these top 5 computers is working on a program called, oh, I don't know, Microsoft Word. Can you imagine how much money Microsoft has made over that one, off that one program over its lifetime? Probably at this point in the billions of dollars. How valuable are those text files? So security was a big concern and still is. But this was another reason companies really liked this model. Like, oh, good, okay, all right. We can maintain security over this. Now, if they trusted the security at that company down the road, they might farm that out and they'd have to string wires down to that company down the road and the server would be in a different building. They might go that far. Now, this is not the system we use today. We don't use a client server model, okay? You're gonna find references to it. Some of the programs that you'll find that manage this whole process are things like Visual Source Safe. You might see references to that every once in a while. Or Team Foundation Server, TFS. There are several different programs that would manage this whole communication and file locking and all that kind of stuff and all the versions. But it's not the way we do things now. And I want you to understand a bit of why. Let's say Alexandra here is a super valuable employee, but she suddenly wants to move to, say, Costa Rica and work from Costa Rica. What's the problem now?
It would be difficult to connect to the server.
Yeah. Now we have a connection problem. We have to somehow let her, with this remote computer, find a way inside this little network. And probably this network is extremely locked down. Only the computers here are allowed to access it. Well, if we let a computer that's, on the other side of the world get inside here, you've got to make sure that that connection is super, super secure, because what's getting passed back and forth are the text files for our most valuable intellectual property. That's a problem. And of course, you guys already pointed out there's a problem. What if both Sudesh and Alexandra want to work on the same file at the same time? The system doesn't allow that. So client server version control gradually went away and was replaced by a different model called distributed version control. Have you guys heard that term yet? Okay. Let's see, what do I like here? Don't like it. All right, we're not even gonna look at any diagrams. We're gonna talk about this for a second. Let's say that instead, we 3 developers, we're all working on the same project. What if each of our computers could at all times have a complete history of all the files? Any one of the 3 computers. Now you've taken this version control and distributed it and its duties amongst many computers. And then if Alexander and Sudesh want to work on something together, Sudesh can work on his piece, Alexander can work on her piece, and you give these 2 sets of changes to this specialized computer program that can handle this type of version control, and it checks to see whether the 2 things can go together without any conflict. And if it can, it just merges them into one new version. If it can't, it stops and tells both of you, hey, listen, a change that you guys are trying to make together has a conflict. Fix it and then try again. That's a very simplified description, but that's what distributed version control is. It's just every computer that's involved in this whole keeping track of the versions of text files has at all times a full history of all of the files. The very beginning, the very first creation of the file, and every change after that. Any questions so far?
Yes, one question.
Go ahead, Suresh.
If you do that, does the feedback to the user, the program, the two developers, is instant, or after when they try to save what they done? Or
It is instant.
is that connected all the time? Okay.
It is instant. Now, again, that was a simplification. What actually occurs is you're never going to have two at the same time. One change will be proposed first, and then once it's accepted, the second one will come in, and that's where you discover the conflict. You're not actually combining two submitted changes at once. Does that clarify that for you?
Yeah.
Okay, but the feedback is instant. I want to tell you a little bit about where the most popular distributed version control tool in the world came from. Do you guys know what this computer program is called?
GitHub.
Git, not GitHub. Git.
Git.
There's a program called Git. Do you know who it was created by? You guys ever heard of the operating system called Linux, right?
Yeah.
Linux was created by a guy named Linus Torvalds. Now, through a very weird coincidence, Linus Torvalds now happens to live about 5 miles from where I live, which I just found out earlier this year, okay? Linus Torvalds created the Linux operating system, which is, by the way, the most used operating system in the world. It's pretty cool. When he was developing this, at a certain point, he said, okay, I need a bunch of people to help me build this thing. And the existing way that version control was done, he disagreed with fundamentally. Client server, no. Even at that point, there were some early programs trying to do this distributed version control, and he didn't like them. So he designed his own. Now, part of the reason he needed to do it this way is because his workforce, the volunteers who were helping him build this operating system, were all over the world. So he needed a system that by design assumed a geographically distributed contributor base, rather than that diagram I showed you before, where the exception was, hey, let's figure out how to let Alexandra work from Costa Rica, and we'll figure out a one-off kind of workaround for her. Instead, it was assumed from the very beginning the computers could be anywhere in the world, and they're all going to maintain copies at all times of all the history. He assumed that, and he designed this program to manage that whole process and let people try to submit their changes, and if there weren't any conflicts, just automatically allow them. And if there were conflicts, just stop it and send a message to the person who's trying to make the change, letting them know, listen, you can't make this because there's a conflict, fix it, and then try again. We're going to look at all of this in detail, okay? But it was designed by this guy, Linus Torvalds. And again, it's just a computer program. And it gets installed on every single computer that wants to be part of a project's code base. They all have this computer program running. You guys have this computer program running on your computers right now. You can tell because you can go to the command line. Let's open up some VS Code action here. I'm waiting for my terminal to open up. And you can go git -- version. And there I am. I have version 2.7.0, Windows 0.1. I have that. You guys could do the same thing. This program is running on my computer. Now, you said GitHub, right, Sudesh?
Yeah.
Here's the basic way to think about GitHub. GitHub is just one more computer out in the cloud that happens to have this program, Git, installed. Now, it's a lot more complex than that, but you need to start from that understanding. If you have a computer out there in the cloud that has Git installed, then even though there's not a developer using that or doing development work on that computer, you could have a copy of your computer program, all of its files, out on that computer at GitHub. Does that help?
Yeah.
Okay, there'll be a lot more about what GitHub is and how it works because it is so popular, but it's not the only provider of the services it has. And everything starts from an understanding of this one program, Git. So we're gonna learn this in little teeny bites, like I like to teach most things. So far, we're looking at this idea of distributed version control, where every developer working on a project will have this program called Git on their computer. And that program lets each of those developers maintain a complete copy of the history of all the files in a project. Let's get a little more practical and start doing a little bit of demonstration of how Git works fundamentally. Cool? All right. So give me a minute. I need to pull up a little bit of a guide here on what we're going to do. All right. We need a brand new folder to work with. So follow along, do what I do. We're going to make a new, it says open folder. And we need a new one here in our repos. I'm going to make one here, new folder, and I call it Git Basics. So make yourself one like that. And then open it in VS Code. So you should have an empty folder here. Now I'm going to keep moving forward at a slow pace. If you aren't caught up, stop me. Let's make a simple text file in here. Oh, wait. Get yourself a terminal. Right now, this is a folder that has nothing in it. We're about to start to make changes in here. We're going to make some files. We're going to edit them. And we're going to look at how this whole keeping track of the history thing works. But first, we need to tell this computer program called Git, hey, listen, you know this folder that I'm in right now called Git Basics? I want you to start keeping track, based on my instructions to you, of all of the contents of this folder. It's a technical term for what we're about to create. A folder that is under the watchful eye of the Git program, so that the Git program can keep track of all the changes in it. A folder like that is called a repo or repository. Repository meaning a collection of things. We're about to use the Git program to turn this folder into a repository, a collection of files and folders that can be tracked by Git. Any questions about that? Okay, the way you do that is using the Git program and giving it a flag, remember, or a parameter of init. Remember from the command line, the first word you write is the name of the program you want to use. The second word, if there is any, is any parameters you want to give to the program. So we're going to run the Git program and give it the word init. And it knows, oh, that means for whatever folder I am in, turn it into a repository so we can start keeping track of history. So do that, git init. And notice the message we get. Initialized empty Git repository in a folder called .git. Well, I don't see a .git over here. Do you see .git?
No.
Huh. It says it did this. It says there's some folder called .git. Well, go to your Windows Explorer, or either of you on a Mac? I've forgotten.
No.
Okay, good. So go to your Windows Explorer, go to your repos, go to this folder we just made called Git Basics. Now, I have here a folder called .git. Do you guys have that folder showing?
Yeah.
Okay, Sudesh?
I'm trying to find repos.
Sure. Or wherever it was that you made the Git Basics folder.
All right, okay. System. Okay.
So have you found that folder yet?
I found the Git Basics, but I can't find anything in
That's
that.
fine. So there's nothing there, right?
No.
Okay, here's the reason why. This, and notice how it's very faint. The folder symbol is really faint. It's like washed out. This is a
Mhm.
hidden folder.
Right.
I have set up my Windows machine to display hidden folders. But by default, when you first install Windows, it doesn't show hidden folders. So watch this. I need you to go to Control Panel. Open up your Control Panel. Tell me when it's open, Sudesh.
Yeah.
Okay, do you see Appearance and Personalization?
Yeah.
Click on that.
Yeah.
Click on File Explorer options.
Yeah.
Go here to View.
Yeah.
And find this thing that says Hidden Files and Folders. You have Don't Show checked, correct?
Yeah.
Change it. And then look down here under Hide Extensions for known file types. Is that checked or unchecked?
Unchecked.
Good. That's the way you want it. You want to be able to see your extensions. Okay. Click OK. And now you might have to refresh with a right click. But do you see your .git folder?
Yeah.
Good. Okay. So when we did the git init command, it made this folder. Well, we're not going to do a detailed tour through this, but I want you in a moment, don't do it yet. We're going to look inside this folder. Inside this folder is where all of the history of the different files and folders you're going to make will be kept. This folder is used by this computer program called Git to keep track of all the history. Double click in here, and you'll see config files and these folders called hooks, info, objects, refs. Right now, you don't need to worry much about that. As you gain more and more experience, you can go a little deeper into this, but you don't need to know very much about it right now. Just know that this folder is where we keep track of all the history, where the Git program keeps track of the history. Any questions so far? Okay, go ahead and close that. Let's go back to VS Code. Well, Now let's start making some files and folders and using Git to keep track of their history. First, let's make a file in here, and we're going to call it file-1.txt. It's just a text file. Now, Visual Studio Code is going to give us some helpful things. We're not going to pay attention to them yet. We're just going to look at using Git from the command line. I want you to go down here to the command line and look at this Git program and give it a Git command called status. And then we're all going to look at the result. There's a few things to talk about here. So, did you all do that? You guys, did you both do that? Okay. This first thing, it says on branch master. We haven't talked about branches yet. Branches are different sets of versions, different complete sets of history of all of your files and folders. We'll look at creating multiple branches and such later. But for right now, just know that you can make a new copy of all of your files and folders and start working on it independent of other copies. That set of newly copied files and folders is called a branch. Right now, we have only one branch. It's called the master branch. Second thing, this word called commit. A commit is a snapshot of the state of all of your files. The way version control works here in Git isn't that every single change you make to every single file is recorded, like every single keystroke or anything. No, you're in charge of when you want to record a snapshot, like a key point in the history of your files. We are in control of that as engineers. And when you take one of these snapshots and you're telling Git, hey, take a picture of where everything's at right now so I can go back to it if I need to in the future. When you do that, that's called a commit. We haven't done any commits yet. You're going to do a bunch of them tonight. Now, we also have a problem here. It says there's some quote unquote untracked files. Well, if a file inside a repository isn't being tracked, that means Git isn't paying any attention to it. But we made a file, but it says it's untracked. That should tell you you need to tell Git to start tracking a file and keeping track of its history. So we have an untracked file. What is it? File1.txt. And it even gives you in parentheses a little bit of hints. Now, Git as a program is very minimalist. It's not that user-friendly in general. It was made by extremely talented engineers who knew what the heck they were doing and didn't give themselves a lot of hand-holding. But there are now some friendly messages you get out of it. So it says, hey, you've got an untracked file. And in parentheses, here's what you could do. You could use this git add and then the name of the file to include the file in what you're going to commit. It also says there's nothing that's been added to do a commit. But we do have untracked files present. This is just more information to you. Git status tells you a bunch of valuable information. What branch we're in, the status of any commits, the status of any untracked files. whether there's anything you can commit. You're going to see this message change. We're going to use get status over and over again tonight. All right, good. So we do have this file here called file1.txt. Let's put some content in it. And put that in there. Now, I want to make sure you all have autosave on, or this will not go the same way for you. When you're done with that, do get status again. It's the same message. We still have an untracked file. Even though we made a change to it, we don't see any messages that indicate that change because we're still not tracking the file. All right, so let's track the file. Git, add, and then the name of the file. Git add file1.txt. Do that. Now notice, again, there's no like friendly little message to tell you that something happened. We didn't get an error, and that's the best you're going to get. But let's do a get status once more. And now it's different. We're still on the master branch. We haven't made any commits, but we do have changes that have happened that can be committed. We added a new file. Well, we could keep on working, but let's say we're like, you know, this is a key milestone in the development of my project. I want to take a snapshot. That's called a commit. So do git commit, and we're going to include a little message with the commit. So do -m, and then in quotes, initial commit. This is our very first snapshot. Now again, stop me if you get behind or if something goes weird. Hit enter. And now we're going to analyze these messages here because it opens up another really important thing. You guys both saw something very similar, right?
Yeah.
Okay, now just step away from the screen for a second and let's just talk through this. We've said that this Git program can keep track of the entire version history of all the files and folders in a project. But let's just talk practicality here. Let's say you have a computer program that has 40 or 50,000 files in it. Hundreds and hundreds of thousands of individual words. Big files, right? If every single time you took a snapshot, an entire record of the entire file as it exists right then was saved inside this Git file, or this Git folder, if we save the entire file and all of its contents for every single snapshot, every version, can you think about how big that collection of files would get? Pretty huge, right? Git does not work that way. What Git actually records when you do this snapshot or do a commit is it records the difference between the way the file was before you made the change and the way the file is after. It only records the difference. The word it uses for that difference is the Greek word delta. Delta is used commonly in engineering to mean change or difference. So that's what actually gets recorded by this program called Git, is the difference or the delta. We go back and look at this message. Notice it says a few things. One, we're on the master branch. This is the very first commit. So it's called the root commit. It's the first commit we've ever made on that branch. It's got this little 7-character thing here. This is a shortened version, or the first 7 characters of a much longer unique identifier that's associated with this commit. So we can look this commit up in the future if we need to. It also has the comment that you made in this message right here. It also records what changed. Only one file changed. It was inserted. It was added. And a little more detail, we created file1.txt. So this is essentially what gets recorded in the history maintained by Git. Hey, we did a commit. That commit has a unique identifier. That commit happened on this specific branch. Here's the exact changes that we're going to record. Any questions so far? Okay. So let's do a git status again. Notice there's very little to say now. Before, when we did git status, it's right up here. We're on the master branch. We hadn't yet done any commits. We did have changes that could be committed, which is that we made a new file. Now, when we do git status, right here, well, it still says we're on the master branch, but it says there's nothing to commit. This thing called the working tree is clean. A working tree is the set of branches. Of all the branches, the one that you're working on, there's a bit of nuance and nerdy stuff there that we're not going to unpack right now. But notice there's nothing to commit. We have taken a snapshot and we haven't done anything since. We took our snapshot by doing this git commit. We recorded all this data right here in that commit. So now git status says, oh, okay, good. Well, there's nothing to commit. We're good? All right, now let's make some changes. Pretend we need to change our code a little bit. Let's change this to, this is revised sample text. Add that in there. And give yourself a git status again. Ooh, look at that. Let's unpack this. Now we're on the master branch. We do have some changes that haven't been staged. Now that's the first time we've encountered this word staged. When you're about to do a commit, you designate of all the available files, which ones do you want to be included in a commit? You don't have to include every change you make when you take a snapshot. Let's say you're working on 2 or 3 different things in a big giant project, and there's only one of them where you're like, I like the state of that. I want to take a snapshot only of that. You first stage that one file saying, hey, this file alone is ready for committing. Once you've done that, then you do your commit. So think of stage as one step closer to a snapshot, marking it as to be included when I eventually do a snapshot. To be included when I eventually do a commit. That's what staging is. So we have some changes that are not staged for a commit. We modified file 1. These are just some hints on what to do. We're not going to look at that yet. We have changes that aren't staged. Well, let's stage them. It turns out that that's the same command we used to add the file in the first place. Git add stages things for us. So we want to add file1.txt to the staged collection of files. So do that. Git add file1.txt. We've now staged it. We haven't made a snapshot. This new text here is not yet part of the permanent record. It's not yet part of our history because we haven't done a commit. Only the commit takes a snapshot and records it in our history. Any questions so far?
If we had like not staged it and then just did the commit, would we have seen the change or no?
Nope,
Oh, okay.
not at all. Because you would have tried to do the commit and wouldn't have worked.
Oh,
You would have
okay.
said nothing to commit. Because nothing was staged for commit. That was a very good question. All right, give yourself a git status again. Now notice here on git status, it said changes not staged for commit. Now it says changes to be committed. We modified file 1. This git status is your lift up the hood and see what's going on with your version control. That's what git status is so valuable for. Well, let's make another permanent record. Let's make another snapshot. Let's do a commit. Git commit. And you have to do an M for a message. Always include a message with your commits. And say, revise the text. We're going to take a snapshot. Boom. Now, I'll show you something here. Let's look at this message here. We're on the master branch. We don't see, I want to compare this to what we had before. When we did our first initial commit, notice it said we're on the master branch, but then it said root commit. Here, we don't see the root commit because this is not the first commit on that branch. We see a little unique identifier. Notice it's not the same unique identifier. Why? Because this is a different commit. It's a different snapshot. It's going to have its own unique identifier. Here's the message we typed in when we did our commit command. Now, this part's super important. We changed a file, and look what it recorded. It recorded that we added something and we took something away. What did we take away?
The previous change?
The previous text. Or more precisely, we took away the single character that was right here. There was emptiness here. We removed that, and instead we added in the word revised. Remember, Git records differences. It records the delta. It records the change only. So what it recorded was, let's do a Control Z here, that what was here before was no character. And what's here after is the word revised and a space. We deleted emptiness and added in content, which is terminology. But we have recorded a diff. Now that's super valuable because we can now go back in history and see what was added and what was removed at the individual character level of a file. Any questions about that? Okay. All right, so give yourself a get status. What do you think it's going to say? Before you do it, what do you think get status is going to say?
Nothing to commit.
Yep. On branch master, nothing to commit, working tree clean. Because we took our snapshot and we haven't changed anything afterwards. All right, now I want to see a history of everything we've done. If you do git and then log, it'll give you a history. Now, there's a lot to unpack here. You guys did this? Okay. This is a record of all the commits. Now, they are in reverse chronological order. You'll notice that the one with the message revise the text, which is the most recent thing we did, is the first one listed. And then the one right before that is the second one listed. They're in reverse chronological order. Notice as well that this says FDCA4, whatever. It's a huge long identifier. Look at that. When we did our commit, we got to see the first 7 characters. Just in the interest of conserving space on the screen, it didn't show us the whole unique identifier. But here it does. Make sense? It shows who wrote it, when it happened, and the message. Now, let's talk about this term head. We've talked about this idea of branches. Another way to think of it is directories. Complete separate copies of all of your files. We've only got one branch right now. It's the master branch. But you can have hundreds of branches, hundreds of separately maintained copies of your code base. We'll look at that later on. So there is, down inside this Git program, at all times, a variable called current directory. You don't ever really see this unless you're poking around. But the Git program keeps track of this thing called current directory in every repository. The current directory always points to the most recent commit that was made anywhere in the entire repository. You might have 100 different branches, and you make a snapshot on one of those branches. Your current directory points to that commit you made on that branch. Head points is another variable pointing to that current directory variable. Now, there's a lot of nuance about why there's 2 different variables. We don't need to get into that. What you need to know is that the head is a variable used by Git that you can look at, and it always points to the current directory. And the current directory is pointing to the most recent commit you made. Well, the most recent commit we made was this one, where we had revised the text. And that was made on the master branch. So you're getting that information. You're not going to have to bump into this too often, but I want you to understand what you're seeing. Any questions so far? Now, this is decent to see this log, but it doesn't show the details. We have our messages, but we don't get to see what actually changed. Let's do our git log again, but do a dash, that's 2 dashes, and the word patch. That will show us all the details. Hit it. And now we see a lot more details. Let's look through this. We see the same information. This is a commit with this unique identifier. This is also the commit that the variable head is pointing to. We already had this information about who did it and when, but now we're recording the diff. What we had before and what we had after. Before is the A, we took something away from that. After is the file B, we added something to it. What did we take away? We took away, this is sample text. We added, this is revised sample text. We can now see every little bit of history. Any questions about this first commit? Now, it's not the first commit history-wise. It's the most recent commit. Well, let's look at this commit right here. There's the unique identifier. Here's who did it and everything. Let's look at the difference. Well, we've got version A of the file and version B. Version A didn't even exist. There was nothing there. Version B, we added the file. Now, again, there's some nerdy details under the hood here. We don't need to worry much about that. If you get super expert at Git, you'll dive into that stuff. I just want to show you that we have a complete chronological history contained here. Any questions? All right, now, let's say that this change I made of revised simple text, that was a mistake. I shouldn't have taken a snapshot. There's more work that I wanted to do before I changed that. I want to erase that most recent commit. We can cancel the most recent commit, but still preserve the changes we made in this file. That is done by git reset head. Now remember, head points to the most recent commit. And then a tilde. Do you guys know what the tilde is at the top left of your keyboard? And then the number 1. We're going to reset to the commit 1 back from the head. Go ahead and hit enter. Now I did the reset, and it says we now have unstaged changes. It even took away our git add. Do a git status and you'll see that. Look at that. I have changes that aren't even staged for commit. I've modified this file. The modification is this right here. I went back in time. I can even do my git log. And look at that. Look at my git log. All I have here my head is now down here on the initial commit. It knows what I tried to do, but it knows that the head is actually down here. All right. Again, there's lots of nerdy details in this log. We're not going to get into all of them. It's enough for you to know that we reset that last commit. That when we do git status, we have gone back to the point where our changes in this text aren't even staged and we don't have a snapshot of them. Any questions so far? All right. Let's say we look at this and we go, you know what? Never mind, it's good. I'm totally fine with it. Let me stage it again. Now, how do you stage something to be included in a commit?
Git add.
Git add, good. And then the name of the file. Let's do that. Git add file1.txt. And do yourself a git status again. There we are. Changes to be committed. If we want to do a commit now, we at least have some changes that'll be included in it. Now let's go ahead and do our commit. Git commit. M went back to new text in message. I like that. All right. Ooh, what if I made a really bad change? Like, not only should I not have done that commit, but I don't even want these changes anymore. I need to go back to what it said before. Let's look at a reset that's brutal. We're going to drop the changes we made in the most recent commit. We're going to drop these edits. We're going to do git reset. But watch this. -- hard. That's a hard reset, means discard the actual changes included in the commit. And then we do the same thing before. From the head, ~1. We're going to go back 1 and we get rid of those changes. Now, before you hit enter, make sure you watch this text up here. When you hit enter, you see the text change. You even got a message that says, hey, the head, the pointer to the last commit, is now pointing at the commit. It was called initial commit. We totally got rid of our changes. Now that's powerful, but dangerous. And you're not going to do it that often, but you can. Any questions so far? All right, let's make this a little more complex. So far, we've been dealing with one file. Let's add a new file. Actually, give us a git status. I always like a git status just to see what's going on. Look at that. We have nothing to commit. We literally got rid of everything that was included in that most recent commit. There's no changes at all. We're back where we were right when we did our first commit, our first snapshot. Okay, now let's add another file called file2 dot text. And put this text is in our second text file. All right, good. So we get some content in there. Now, let's make another file. I'm going to call this config.json. I'm going to put some JSON in there. Let's see, username, Eric, password, Don't steal my password. It's private. I'll give you guys a minute to get caught up. You guys caught up?
Yes.
Sudesh?
Yeah.
Okay, good. Now, let's say this config.json file, I only care about it locally on my machine. Maybe I'm using this to connect to a database that's only on my machine for development purposes. In other words, I don't want anybody else who's going to be using these source control files to use this. I don't even want to keep track of it in source control. I want Git to utterly ignore this file. If I make changes here, I don't want Git to even keep track of them. There's a way to do that. You make another file out here, a very special file called .git ignore. Make sure you do dot first, .git ignore. Any files you list here, Git will ignore them. So type our config.json in there. And now let's make it another change. Let's go back to our file 1 and add in more. This content was added at the time we created the .git ignore file. We just made a bunch of changes. Now, don't cheat on this. If we do a git status right now, what do you think it's going to tell us? Not specific nerdy details, but in high level, what will git status say is going on?
Will it show like, oh, sorry, Sudesh, go ahead.
Sorry, is it changes not staged for commit? Or?
Yeah, but what kind of changes is it going to say that we've done?
Lots.
Lots. Good. Well, look over there and just tell us what changes have we made. We added a git ignore file, right?
Yeah.
We added a config.json file, right?
Yeah.
We added a file2.txt, and we changed file1.txt. What do you think the git status is going to tell us? Will it tell us all 4 of those changes? Just take a stab at it. We'll get status, tell us about all 4 of those changes. The creation of get ignore file, the creation of config.json, the edit to file 2 or file 1, sorry, and the creation of file 2. We'll get status, tell us about all of those. What do you think?
It won't yet.
It won't?
No.
Why not?
Because we haven't committed.
You're right, we haven't committed. But get status at any point should be able to keep track of any changes you've made.
Yeah.
Changing them and committing are 2 separate things. You make a bunch of changes. When you commit is when you make a snapshot of those changes. So we have, in fact, made some changes. Get status should be able to tell us what changes we've made. Let's do it, and we'll unpack what it says. Get status. So here's our get status. Let's go through this slowly. Well, we're on the master branch. We knew that. We have changes that we have not staged for commit. We modified this file 1. We also have untracked files. Now, this is super important. It says we have a .getignore file that's untracked, and we have a file 2 that's untracked. It doesn't say we have a config.json that's untracked. Why not?
Because it's in our .getignore.
Exactly. The Git program certainly knows that this was created, but it also knows there's a file called getignore, and it looks at it and goes, all right, if I have a file that matches this name, then I ignore it. So it doesn't tell us it was untracked. It won't tell us anything about it ever. Does that make sense, Sudesh?
Yeah.
Okay, so I have 2 things here, though, that I potentially would want to be included in a snapshot. Now, I've made a bunch of changes. I do want to make a snapshot right now. Now, I have the fact that I changed file 1, and I added the getignore and file 2. All of those things, I want to stage them and get them ready for a commit. What's the command for staging?
Git add.
Yes. Now watch this. Don't hit enter yet. Type git space add and then space. Now, what are the 3 files that I need to add here? Sudesh?
The ones highlighted red.
Yeah, file 1 text, .getignore, and file 2, right?
Yeah.
There's a shortcut that Git gives you. If you want to add all the files in the current directory that either could be staged or aren't tracked, if you want to add all of them, just put a dot, which means the current directory. And the Git program will find all of these, and even the ones that are in nested folders. And if they're capable of being staged or added, it will do so. You don't have to type out the individual name of each file. Make sense?
Mm-hmm.
Good, do that. And now give yourself a Git status. And now we do have changes that could be committed. We've staged our 2 new files and our change to file 1. If we want to take a snapshot now, we can. Now, we don't have to. We could keep doing work. But I think we're ready for a snapshot. Let's do a commit. And I think I want a added file 2 and get ignore. I like that. Boom. Now look at that. 3 files changed. 4 insertions and 1 deletion. We created get ignore and we created file 2. What's the deletion we made? Any idea? Let's find out. Do a git log with dash patch. Is it dash or dash dash? Give me a second. Dash dash, yeah, dash dash patch. Let's look at all the details. Let's see, there we are. Git log dash dash patch. Well, the head is pointing to this most recent commit that we just did. It was the commit with this message. All right, so let's look at this. Well, we've got a add of the get ignore. We have a new file mode. Look at this. It knows. It knows we added config.json, but only as the content of get ignore. And look at this, the subtraction, we had a nothing and we added in content. And now I have another diff for file 1. We had this is sample text. What we added in is this is sample text plus the second line. So you can see all the changes we made. Now, again, you're rarely going to go into all this nerdy detail under the hood. But I just want to point out that this Git program lets you utterly control at what point you want to designate some of the work you've done as this should be included when I next make a commit. And it gives you utter control over when you make that commit. The fact that it gives you all that control, though, means you need to be smart in using it. And so in later classes, we'll dig into strategies around how to use the tool. Right now, I just want you to understand a bit of what it does. Under your direction, it will maintain a history of all of your files and folders. You have to tell it when you care about the history, when to take a snapshot. If you screw something up, you can go back in time and reverse the changes you've made. How are we doing? Any questions? Okay. Go
I have
ahead,
a
please.
quick question.
Yeah.
So like when you do the git ignore, like you add the file you want to ignore, is there any time when you wouldn't want like even them to see like to even record like what you're ignoring?
I don't think so. Tell me about when would that be valuable? When would you think that would be a useful thing?
I'm not sure.
Okay,
Maybe
that's
if you
fine.
name something weirdly, I don't know.
Oh yeah. Well, here's the thing to know is that no. The answer to your question is no. Everything gets recorded. Now, I do want you to want to point out in terms of the permanent history, The permanent history doesn't know that you made a file called, or it doesn't know what the content of config.json is, because that file isn't being tracked. All we do record is that in the config.json, at least we know there's a file called config.json, and that's all we know, and we're not tracking it. Now, if you call that file something obnoxious, like I'm a big idiot.jpg, well, it'll know that you made a file called I'm a big idiot.jpg, and you're not tracking it in version control. And that'll be available to anybody who has access to this version, this repository.
Okay.
And its history. Make sense?
Yeah.
Good. Excellent. Good question. I like that. Okay. All right. That's going to be it for now. We're about 15 minutes over. There is, let's see if I can find this. I have to look something up. Give me just a moment. Okay. I want you to start reading through this tutorial. I'm going to put it on the screen so that anybody else watching this will be able to see it. And then I'll leave that. That's recorded so people can. And then I'll put that in Discord for everybody. What is going on with my mouse? Being funky. I want you to just go get through as much of that as you can before Wednesday when we have our class. Okay. All right. That's a lot of stuff. How y'all doing? You doing pretty good?
Yeah, thanks.
Okay, good. Awesome. Okay, that's it. Have a great night. I will see you in 2 days.
All right. Good night.
Cool.
Thank
Bye
you.
all.
Good night.